Hello everyone, this is Mr. Appel, and today we're going to look at solving quadratic and square root inequalities algebraically and using the graphing calculator. So let's get started. So here's a basic quadratic equation. You should know how to solve this algebraically. I made it nice and easy. It's factorable. Of course, if it's not factorable, you'd use quadratic formula or completing the square. I'm just going to walk through this really quickly. We factor, set each one equal to 0, and you find your solution, piece of cake. So in this case, that's definitely the easiest way to do it, but I do want you to know how to solve this using your graphing calculator. So using your graphing calculator, you would go ahead and put the function in. What you're doing is you're trying to find the value or values of x for which the function y equals x squared minus 4x minus 12. When will this give you an output of 0? So what you're going to do is go to your y equals screen, put that function in, so that's x squared minus 4x minus 12, and we're going to go ahead and graph it. I set to the standard window. We'll see if that works for us, and you see we can actually see pretty nicely where this thing equals 0. It's right over here and right over here. And that's consistent with what we already knew, which is that x equals 6 and x equals negative 2 are the two zeros of this function. But if you hadn't done this algebraically and you wanted to confirm exactly where those zeros are, we can use the calculator to do that. So we're going to press second calc, which is above the trace button, so second calc. Here we're not finding intersections like we did before, we're finding zeros. Zeros are just when the output of a function is 0. So we're trying to find when that happens. So second calc, and then choose number 2. You can arrow down and press enter, or just press 2. And this works a little different than the intersection. We want the left bound and the right bound. So let's say I wanted to find this particular 0. I'm going to move the cursor over. You see it was off the screen there, but down here it tells you it's at x equals negative 1.4. I need to go a little further over. So I go past it, press enter, that's the left bound. Then the right bound, I want to arrow over to the right so that I'm on the other side. Remember, we're thinking left, right here. So now I'm on the other side, make a guess. So I'm going to move the cursor as close as I can to the 0. And there it is, x equals negative 2. And then we could do that process again to find the other 0 over here, which is 6. So that's how you use your calculator to solve a quadratic equation, to find the zeros. Now, let's step it up a notch. Let's say we wanted now to find not when does that thing equal 0, but when is that thing greater than or equal to 0. I'm going to start with the graphing solution because that's actually easier to see. If you look on this graph, the question is being asked here, if this is your y1, is when is that bigger than 0? When is it above 0? And we see that that occurs. Sorry, having some technical difficulties here. Oh, come on, don't make me start this whole thing over. Oh boy, here we go. All right, well, I'm going to try to keep going while the computer's bugging out on me, and we'll see what happens. So I see that that happens over here to the left of negative 2. My graph is above 0. And over here to the right of positive 6 is also where it's above 0. It's not above 0 in between the two, because you can see here on the graph it's below 0. So this is an example where the graph is probably easier to work with than an algebraic solution. If you were, so your solution then would be x values that are less than or equal to negative 2, or x values that are greater than or equal to positive 6. In interval notation, that would be negative infinity to negative 2, combined together with 6 to infinity, and that one should be a square bracket as well. Okay, but algebraically what you would do is you would sketch on a number line. We would still use a number line for our algebraic solution. And you can either, so what we want to do here, those are the places where it equals 0, which means when it's not there, it's either positive or negative, right? Because if it's not 0, it must be positive or negative. So I want to look at each of these three regions, over here to the left of negative 2, over here in between negative 2 and 6, and over here to the right of 6, and see what's happening. Now, if we can picture in our minds what this graph looks like, I know because of the positive leading coefficient that the graph is going to do something like this. I'm getting a little error message. We're going to keep going here. then I know that the y values are positive here, negative here, and positive there. If you're more of an algebraic thinker, what you can do is just pick a value, an x value, in each of these three regions. So maybe I pick x equals -3 and plug it in. And if I pick -3, I get 9 plus 12 is 21, minus 12 is 9. I get a positive number. In here, if I pick an x value, let's say 0, that's 0, minus 0 is 0, minus 12, that's -12, so I get a negative answer. And if I picked a positive 7, 7 squared is 49, minus 28, minus 12, and I get a positive answer. So I can see that it's positive here, positive here, but I can see that on my graph as well. So to answer this question, when is y1 greater than or equal to 0, it's here and here. And that would tell me that my solution is that and that. So that's how you would do it algebraically, but here I think actually the graphical solution is easier. Okay, next up, radicals. So let's look at this radical equation. Let's first look at the domain. So the domain, remember, is all the x values that don't make this thing blow up. What makes this thing blow up is a negative under the radical. So let's look at each radical separately. So I need that x plus 4 to stay non-negative, in other words, bigger than or equal to 0. But I also need this expression to be, I need this expression to be bigger than or equal to 0. So I'm going to just solve each of those separately. So that's x bigger than or equal to -4. And this one, I have negative x bigger than or equal to -6. And if we divide, remember the inequality flips. So less than or equal to +6. So my domain is all the numbers between -4 and 6, including -4 and 6. Okay, so that's our domain. Keep that in mind because that's going to be important in just a minute. Okay, now let's look at our calculator. So let's go back to our graphing calculator and put those two functions in. So square root of x, I missed it, x plus 4, that's our y1, and our y2 is square root of 6 minus x. And there's my second one, and notice I made that one dark, so it'll be easy to see on the graph by going over there and just pressing enter to make that a thick black line, so it'll be easy to see that that's y2 and the other one is y1. I'm going to graph. If your window doesn't look like that, remember to do zoom 6. And here's what I see. And what I see is the x plus 4, my y1, is this one, and my 6 minus x squared to 6 minus x is going the other way. Well, what's the question asked? The question's asking, when are they equal? Where they're equal right here somewhere. How can we figure out exactly where? Well, you could zoom in a little bit when you change your window, but really we just want to find the intersection. So let's calculate the intersection. So second calc, intersect, like we've done before. First curve is square root of x plus 4, that's y1. Second curve, y2, so I'm going to press enter to select those. My guess, that my cursor is pretty close, so I'm going to just press enter for my guess. And we see that when x is 1, that's where they meet. So my solution to this equation then is x equals 1. And that is my answer. And you can see if you plug 1 in, those two are in fact both the square root of 5, and it works. Okay, now let's step it up a notch for an inequality. Now I'm using the same 2, so you don't have to write in 2 new functions. But again, this is going to be my y1, this is going to be my y2. Now here's where the domain is really important. Remember our domain was from -4 to +6. Okay, well look on the graph, and I want to actually change my window a little so I can see this a little bit better. So I'm going to change my x's. This is -4, so maybe I'll go out to like -6 to maybe positive, that's 6 right there, so maybe 8. So let me change my x values to go from -6 to +8. Get a little bit better view of what's going on there. Notice that my y values, there's nothing below the y-axis, the x-axis, I'm sorry. So let me change my y minimum, set that to 0 because I don't need to see any of those negatives. and maybe knock this down to like 5 so I can get a really good picture of what's going on here. So see, now I can really see what's going on. And here's the key. The question says, when is y2 bigger than y1? So let's just look at y2 over here. Okay, let me see if my pen will work this time. Okay, so here's y2, right? So is y2, let's say right here, is that bigger or smaller than y1? Well, it's below, so it's smaller, so this doesn't work. Right, smaller, 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 all the way here. Here they're equal. Now here is where they become bigger. So you see now that y2 is bigger than y1. As I keep going out, it's bigger, bigger, bigger. So it looks like any x values to the left of -1. So in other words, when x is less than or equal to 1, that the y2 is bigger than y1. But we have a problem. What happens if I go out to, let's say, here? Is this higher, give you a higher output than y1? Does y2 here give you a higher output than y1? Well, y1 doesn't exist out here. It blows up. There is no y1 out here. So can you really say that this value is bigger than this one when this one doesn't exist? The answer is no, you can't say that. It doesn't make sense. This is where the domain is important. And if you look on our graph here, let me change colors here, the only part of the graph that makes sense is from here to here when we're comparing the two, because if one of them blows up, no good. So we see that our solution is just this area right here. So it's only the x values in our domain that will be part of our solution here. So this is actually incorrect. It's not less than or equal to 1. It's less than or equal to 1, but also has to be greater than or equal to -4. So our solution then would be from -4 to 1. All right, I hope this clears things up, and good luck. Thanks.